All right, I wanted to take a second to just do like a little intermission in the videos to cover some terms that are related to hardware and some other terms that people interested in computer science and programming should know. So the first is CPU, which is the central processing unit. It's the processing chip that serves as the brains of any device that interprets or processes the digital instructions provided by applications. So it's processing all those ones and zeros, and that our code gets converted into, which is binary. So a bit, what is a bit? A bit is a piece of information. It's an abbreviation for binary digit, which is the smallest piece of information used by a computer. So, as I was just talking about, it's either a 1 or a 0. Those are the binary digits that make up computer language. Bits are literally the foundation upon which computer science is built. So, in modern computing, information is stored and processed at a scale that is orders of magnitudes larger than an individual bit. And so, here's a conversion right here, just for quick access. So, 8 bits is a byte. A kilobyte is 1,024 bytes. Megabyte is 1,024 kilobytes, and a gigabyte is 1,024 megabytes. And obviously, you just keep going from there. RAM, random access memory. So that's a hardware component. I think a lot of us are familiar with the RAM in our computers, the sticks of RAM that we install on those computers or that you have in your computer. You can usually see them. So RAM is very quick, and it's a hardware component that stores data that is actively being used by the processor. So when it's needed, information flows to RAM storage from long-term secondary storage, typically like a hard drive or an SSD. Secondary storage is the next topic, of course, which is, like I said, it's a long-term data storage option. So that covers like HDDs and solid-state drives, SSDs. So when you save a file on your computer, it's sent to that secondary storage device. Some like databases that we will cover at some point in programming store information in RAM, so they're very, very fast. Redis is one that does that. So if you are interested in that, you can read up on Redis. ROM is read-only memory. So this is memory that can only be read from, and it is not electronically modifiable after being manufactured. So computers use ROM to store critical foundational information like startup processors and software instructions, which is good because then we can't access it and mess it up, right? Input-output devices and I/O you'll hear a lot. So that's input and output. So it refers to anything that we use to input information to a computer or to take information out. So like a keyboard and mouse, those are input devices. Printer and speakers are output devices. So then we have algorithm. So at a basic level, they're just specific procedures used to solve computational problems. As our computing power and data capabilities have gotten more sophisticated, so have algorithms and the problems that they intend to solve. A shipping company might use an algorithm to help determine the optimal route for delivery drivers, and they do, and you'll see that algorithm. I'll butcher the name if I try to pronounce it, but basically it breaks down routes into sub-routes, and it picks the fastest sub-routes and kind of scores them, and then the lowest score wins, and that's how we get location data for like direction somewhere. An API. So this is something that you'll hear a lot, and this is a term that was not explained well when I first heard it. So it's an app. It stands for Application Programming Interface. So it's a software go-between that brings information from one application to another. It allows applications to communicate with one another while having some level of security measures for each endpoint. So this could be like from a web browser to a mobile app. This could also be like a full stack web development, which is what I do. It could be from like a back end to a front end. Like you'll use an API for that, even if you build the back end and the front end. Typically, it will use like some security measures in between the two, so that people can't just hack your website, right? And then you'll usually have external APIs built into that, where you're contacting someone externally for data. And we'll build apps at some point, and you'll get first-hand experience with APIs. But just know that API, while it sounds confusing, is really just sending information back and forth with applications. So just multiple applications, and that could be through multiple computers or the same computer. A lot of times you'll run the back end and front end on your own computer at the same time, and you'll see them communicating information back and forth. Boolean we've covered, which is kind of like the true or false or a yes or no. Bug is a programming error that causes unexpected glitches or problems. And we use a process called debugging, where we go through and try to solve that. And over here on VS Code, you actually see this run and debug. So that is something that you can use to debug a program before you launch it to production while it's still being developed. So I'll just touch on development and production really quick. Development is when you're working on something. Production is kind of what you would launch to the end user. Hopefully, the production is nicely packaged and operates bug-free. That's just in an ideal world. Obviously, that does not happen. I think we've all ran into plenty of bugs using plenty of software, especially like video games or anything large scale. Camel case and snake case I covered, I believe, in episodes 1 or 2. So if you are confused by those, just go back. These are things you should know. Code is just a string of commands or directions used by different programming languages in order to create, edit, or manage computer programs or applications. So it's just telling a computer which actions to take. It defines the parameters and more. Compiling is the process of taking code that's written in high-level languages, something like C++, and translating it into machine-readable code. Not all languages are compiled languages. Like you have scripting languages, like JavaScript specifically. And then we have conditional statements. We've touched on those a little bit. And just really quick, like Python's also not compiled. It's, for the most part, an interpreted language. So compilation is a step in Python code, which technically, like the .py file is the first step, which is converting it to like bytecode. So if you want to read up on that, you can. I'm not extremely knowledgeable on the compiling process with Python specifically, so feel free to read up on that if you want. Conditional statements are like your if-thens. We've done some ifs. If you remember in the strings, we were looking to see if a string contained any of the other characters. So like, for instance, we looked for the case-sensitive name Dan inside of a string to see if it contained that, and then if it did, it would print something. If it didn't, it wouldn't, or vice versa. If it wasn't in there, it would print something, and if it wasn't there, it would not. So that's a conditional statement. Then we have integrated development environment, or IDE. It's just a software tool where you can write code and run programs. So that's what VS Code is. This is an IDE. So this allows us to do like the terminal and execute it in here. VS Code's an excellent IDE, in my opinion. Scripts and latency. So let's do latency first, sorry. It's the measure of time between entering an input and returned output. So you send something off and how long it takes for something else to be the output, right? Several things can affect latency. So the higher it is, the longer it took. So you want a low latency whenever possible. You'll see kind of like a latency complaints with like satellite internet, for instance, and that's something that Starlink, if you look at how their model is, they have multiple layers of satellites to try to combat latency and make it as low as possible. This is an important factor for web apps, especially if you're having like multiple API calls, as we call them. So like you write a piece of software at a database that sends data to multiple users. You obviously want the lowest latency possible. That's where storing something in RAM is important. And that's why like Redis or something like that can be very useful, because if you're having massive amounts of people, say like log into a social media website like Facebook, right? They probably have millions of people logging in throughout the day. So it's very useful if that data can transfer really quickly with a very low latency. So scripts, similar in the way like scripts are used in kind of like the movie industry. A script in programming terms is just a line-by-line set of instructions for a computer program to follow. So it's used a lot for like automation and generating dynamic page content, like JavaScript, right? We're generating dynamic page content in websites, which basically what that means, like to generate dynamic page content, that means you're taking something that a user's inputting and you're changing the output of the page. So Like if somebody posts on a forum or like posts a picture on Facebook or something, that's dynamic. So structured data, which is just data or information that's been organized and cleaned, quote unquote, in order to make it easier to search, manipulate, and interface well with software applications. So structured data is, I've spent a long time trying to mess with data that I get to structure it. Like if you ever work with a web scraper, which just scrapes websites, and like even Google, right, like they crawl websites, they need a way to structure that data. So stuff like names, addresses, credit card information, really any quantifiable data category. And then we have syntax, which just refers to the rules that dictate the structure of a language. So when I was talking about like Python syntax, a big thing with Python is the indentation. And other languages are less picky about indentation, although you should still try to make your code as readable as possible, and that's the purpose in a lot of languages for indentation, is to just make code readable for humans. And Python will not execute code if your syntax doesn't meet their standards with indentation and stuff. It will actually cause errors. So while some elements of syntax might carry over from language to language, most languages have kind of a unique and specific syntax, and if you're learning any language for the first time, you should familiarize yourself with that syntax because it will avoid a lot of headaches. So I just wanted to cover those terms because you might hear me throw out a lot of those terms, and I wanted to just give a quick video where I explain all of those a little more in depth. And of course, feel free to research any of this stuff on your own.